All right, today is lesson 5-6 in your algebra book. Your big idea: the distribution of probabilities of all possible outcomes from a situation can be displayed in tables and graphs. So that's kind of a real wordy big idea. Basically, we're going to look at finding the probability of events and looking at odds, outcomes, things like that. So quick on your definitions here. An outcome, we're going to use that word a lot, is the total number of possibilities. So all of the outcomes means all of the possibilities. An event is the set of desired outcomes. So the outcome is all the possible things that could happen. An event is just one of them. The probability of an event is always expressed as a number from 0 to 1, and it tells you how likely it is to happen. And that, if you think of numbers from 0 to 1, those are decimals, fractions, and they can be expressed as percents as well. We're going to see that. And when we see this form right here, P and then in parentheses E, that is read the probability that event E will occur. So there'll be something inside of here, inside the parentheses, that we're trying to find the probability of. So that's read the probability of whatever's inside. We're going to see the words unbiased or fair. A lot of times they'll say a fair dice is rolled. And what does that mean? That means all outcomes have the same probability. So there is such a thing as a weighted dice, where one side is more likely to be rolled than another. But a fair dice means all the sides are just as equal to come up as the others. And complementary events, very important. When two events don't have any elements in common and they contain all possible outcomes. So these are two things that together make up all the outcomes, and there's no overlap, like heads and tails. Those are complementary events. And we'll talk a little bit more about that in a second. So rolling into example 1, no pun intended. One die is rolled, that's a dice. One die is rolled. We're going to calculate each of the probabilities. So first of all, we want to think about, in a dice, how many outcomes are there? All the possible outcomes for rolling a dice. You could get a 1, 2, 3, 4, 5, or 6. Okay, so the total number of outcomes is 6. And so when it asks, what's the probability of getting a 1, you're going to put the event over the outcomes. And there we go. So how many different ways are there on a dice to get a 1? Just one. And the total number of outcomes is 6. Now we can leave it as a fraction, but we can also divide this, turn it to a decimal. Usually when they're expressed as a decimal, they're going to go just 2 spots. So it's 0.16, but it's going to get rounded up to 0.17. Now, you could call that 17%, but technically with a percent, you're going to go 2 spots. So if we were going to round up to a whole number percent, you would say 17%. If you were going to go one more spot, you'd say 16.7%. So either one is fine. Let's just call this 17%. But know that you could express it as 16.7% if you wanted to be a little more precise. Okay, so your answer can be left as a fraction, a decimal, or a percent. So what's the probability of getting a 6? How many different ways to get a 6? So on this one, some people would say, well, there's one way to get it. But they'll also say, well, I saw a 1 here, so there's a 1 here. So if there's a 6 here, I should put a 6 here. And that's not true. The total number of outcomes is still 6. There's 6 different things I could get. And how many of those outcomes are this event? A 6. Just one of them. So there's only 1 out of 6 ways to get a 6. So of course, you could express this in all these different ways. So what's the probability of a 7? Well, the total number of outcomes is still 6. How many ways can you get a 7 on here with one dice? 0. And we're just going to simplify that to just 0. There's a 0% chance. Probability is 0. So again, when we look at these decimals, probability is always between 0 and 1. So this decimal, 0.17, is between 0 and 1. 1/6 is between 0 and 1. So 100% will be 1, 0% will be 0, and pretty much everything else is in between. So what's the probability of a number 3 or higher? So again, it's out of 6. So if you look at your outcomes, the number 3 or higher, there's 4 out of 6, which we would simplify to 2 out of 3. What's the probability of a number less than 3? So there's only 2 less than 3, so 2 out of 6, which equals 1/3. And if you look at these two fractions, these are going to add up to one whole because they represent all the possible outcomes, and there's no overlap here. Okay, the probability of a number less than 3 is these two numbers. The probability of a number 3 or higher is these four numbers, and neither one of these share any of their events. Okay, so these are called complementary events. Okay, so together they make up all of the possible outcomes and they don't share anything. Okay, so if this is 1/3 of the probabilities, then this is 2/3 of the probabilities, and together that's one whole. That's what makes it a complementary event. All right, example number 2, we're going to look at using some playing cards. So if a card is randomly pulled from a deck, we're going to calculate what's the probability of a king. So some things that we need to know. If you don't know how many cards are in a deck of cards, we're going to need to write this down. There's 52 cards in a deck. There are 4 suits. The suits are your hearts and diamonds, which are both red. And then your other one's a little harder to draw. Let's see how well we can do here. Not great. Something like that. So your clubs and your spades, these would be your spades and these are your clubs. But these consider the black cards. So half of the cards are red, half of them are black, and those are even split into 2 equal pieces. So each one of these represents 1/4 of 52. So if you divided 52 by 4, you're going to get 13. So there's 13 cards in each suit. So what are those cards? You're going to have a 2 of hearts, a 3 of hearts, a 4 of hearts, 5, 6, 7, 8, 9, 10. And then you have your jack, queen, king, ace. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So 13 hearts, 13 diamonds, 13 spades, and 13 clubs. Okay, so there's your deck of cards. So what's the probability of getting a king? So the total number of cards, the total number of outcomes is 52. And there's 1 king that's a heart, 1 king that's a diamond, so on and so forth. So there's 4 kings. So it's a 4 out of 52, which we would simplify down to 1 out of 13, dividing by 4. What's the probability of the ace of spades? Not any ace, the ace specifically of the suit of spades. So there's only one of those out of 52. What's the probability of getting something that's not an ace of spades? So any card besides the ace of spades. Well, there's only one that is the ace of spades. That leaves 51 cards that are not. And again, these are kind of like you would call them opposites. So together, these make up all the possible outcomes. They don't share anything. Okay, and these are called your complementary events. All right, let's flip it over. So real quick, we want to talk about odds. Odds are a little bit different, and it can get a little confusing between the two. So it says your odds of winning an award are 2 to 1. And then let's see what this says. This means that you would be selected 2 out of 3 times. So your probability is 2 out of 3, but your odds are 2 to 1. So when we're looking at the probability, so we already just answered this question. What's the probability that you get the award? 2 out of 3. So this compares, like we said on the front, your outcomes to your event. Odds compare your event to its complement. So 2 to 1 is saying there's 2 ways you can win, and there's 1 way that you can't win. So that's a total of 3 different outcomes. 2 of them in your favor, 1 of them not. So it's comparing 2 wins to 1 loss, total of 3 games. So you won 2 out of 3 games. So your odds are comparing the event to the event not happening, the complement, where probability is comparing your event to the total number of outcomes. So there's a slight difference there. So what's the probability you will not get the award? That would be the complement. There's a 1 out of 3 chance. So it's important to see the difference between your odds and your probability, just a different way to express it.